sandstone, but basically if you look, you'll see where units kind of pinch out, and they're at an angle to each other. Particularly where it's in weather, you can see the look at that. We're going to see much better examples of drying. But you're all looking at nice sandstone. This is pretty quartz rich, a little bit of iron in it gives it that yellowish color, yellowish orange color. So this is some of the sandstone. This is probably Jurassic, getting towards Cretaceous age, so about 170, 180 million year old rock.
How old is the world?
4.6 billion. So, just want to take a quick stop, make sure we're looking at the rocks as we're coming down. This is a bonus stop. Meters, so they're not always fixed. It's just we didn't move that far.
Weather
5, 6, 9.
Well, you need altitude too. Oh, elevation. Oops, I went a little too far. The elevation here is 3,099 feet. I'm going to explain what we're going to look at when we climb up to the top of this hill. And basically what we're looking at is this. We have an anticline, which we talked about last night, which is where the beds get compressed and then they fold upwards. That's pretty good. This folding occurred during the severe orogeny 70 million years ago. So these rocks are actually older than 70 million years ago that got folded because they had to be there to be folded. I drew a block diagram, and so if we look at a cross section, there's your anticline. But unlike a regular anticline where the what we call the hinge line, this kind of crest of the peak is what we call the hinge line. In this case, the hinge line is actually pointed into the ground, and as a result, when you look at the ground surface, it creates a V. So when we get up on top of this ridge and look down on the inner part of the Virgin Anticline, you're going to see these beds make a beautiful V shape. And that's because the hinge line is plunging this direction into the ground because it was not horizontal. Does anyone have a loose piece of paper I can borrow? Just need one piece. There. So basically what we're looking at is we have our anticline like this, right? But instead of the hinge line being parallel to the surface, it actually plunges down like this, and then the top part gets cut off, creating this V shape.
Oh, I see.
Okay? Here's your paper. So that's what we're going to look at. And so if you imagine if you were to take this unit and flatten it back out, this unit would be on the bottom, this unit would be on top. Does that make sense? And so when
can
you look,
say it again? I'm sorry.
well, the older unit, if we were to take this and flatten it back out, instead of being pinched, we flattened it back out, this would be on the bottom and this stuff would be on top.
Yeah.
And so when you look at the Virgin Incline, the units in the middle will be the oldest units, and the units on the sides going outward progressively get younger. So when we were driving up the Pine Valley Mountain, the units were actually getting younger and younger and younger.
What's is it the plate that drives it together? Or?
Yeah, basically the Farallon plate and was subducting under North America off to the west. Some kind of small continental material like an island arc or something got sucked into the trench at subduction, collided with North America, and created a compression, like a collision. And over here in Utah, that is expressed by faulting, called the severe orogeny, that thrusts stuff from the west to the east. And one of the expressions, instead of faulting, you got folding. And so this is a compression. That's a result of that, what we call the severe orogeny.
Does folding require heat?
No. Heat can help, because when you fold something, it means it's generally been very deep. It was under more pressure and probably a little bit of heat as well. And so the rocks tended to fold, whereas where you got faults, the rocks were probably a little closer to the surface and they broke. So they behave more brittly.
So it's safe to say that the Colorado River and the where this plate tectonic meets in Northern California. The fault line is like dead center right now, or kind of dead center between the two.
Kinda, but remember the
How-
San Andreas Fault at the time this was being formed didn't exist.
Oh, okay.
The San Andreas Fault is only about 20 million years old. This feature happened 70 million years ago.